All right, so in this video, we're going to be looking at applying properties of derivatives to some expressions involving more than one function. So we're going to start with taking our derivatives, since that's the first thing that we're asked to do. And then after we take all of our derivatives, then we'll circle back around and we'll evaluate them at the given point. We have some information on both the functions and the derivatives at that given point, which will apply to whatever expression we get for our derivative. So let's start with our first function. We're being asked to take the derivative of f of x, but f of x is depending upon some scalar multiples of a of x and b of x. So when we take our derivative, we'll apply properties of the derivative to that problem. Now, properties of the derivative that are applicable here include the fact that when we add functions together, we can take the derivative of the two functions separately. Same thing when we're subtracting, since subtraction is just adding with a negative. So in this case, our first step will be to say that we're going to split these up into two terms. Take the derivative of that one, and then we're going to take the derivative of the second one. Again, I'm writing this out mostly just to show you what my reasoning is. And then because there's another property of the derivative that says we can, if we have the derivative a function times a scalar, we can take the scalar out and then take the derivative of what is left. So I can take the 9 out. And now there's nothing left except to take our derivative. So we end up with 9 a prime of x minus 7 b prime of x. Now, again, that should seem like it's obvious, and I didn't need to show that many steps. And normally, if I was writing this out myself, I would go straight to the answer. But again, that's the thought process that we have to keep in mind. All right, now in this case, this is a product rule. And so if you recall our product rule, we can express our product rule, let's say PQ of x, take the derivative, it's going to be P prime times Q plus Q prime times P. And again, I'm just keeping the function notation kind of collected just to kind of keep it short. So that's what we're going to do here. And so all we're going to do is we're going to apply the product rule. So B prime F prime of x for this part is B prime of x C of x plus C prime of x B of x. And because this is all adding, we can put these in any order we like. Now, the next one, of course, is just the quotient rule. And so if you remember the quotient rule, our derivative of P over Q is P prime Q minus Q prime P divided by Q squared. And in this case, we do have to be careful about the order. The thing from the denominator is the one that gets the negative sign on the derivative in the numerator, because subtraction is ordered as in addition is not. All right, so for this problem then, f prime of x would then become a prime of x C of x minus C prime of x, A of x, divided by C of x quantity squared. And then finally, this one's a little bit more, it looks a little bit more involved, but it's still basically just a quotient rule. The only difference here is we have subtraction in the denominator. We cannot split a fraction on subtraction in the denominator. We can split it in the numerator, but we can't do it in the denominator. So our Q function in this case is B of x minus C of x, and that's fine. So F prime of x, using the same quotient rule as above, is going to be A prime of x times the original B of x minus C of x minus, using our properties from part A, B prime of x minus C prime of x, that's our derivative of the denominator, times A of x, all divided by B of x minus C of x quantities squared. So this is our P prime, and this is Q, and this is Q prime, and this is P, and this is Q squared. All right, so now we have all of our derivatives evaluated as derivatives. And so now what we want to do is we want to go back to the beginning and plug in the values that will evaluate it at the given point. So here's our expression for our derivative. So F prime of -2, we're going to plug in the values we have from above. So 9 times, well, what is A prime of -2? It's 5 minus 7 times, what is B prime of -2? It's 6. And so we end up with 45 minus 42, which is equal to 3. So that's our answer for part A. And then for our next case, again, here's our derivative. And we're going to, again, plug in the values that we have. F prime of -2. Well, we have B prime of -2 is going to be 6 again, but the C at -2 is 4. And then we're going to add C prime at -2 is -3. And then B at -2 is 2. And so when we evaluate that, we get 24 minus 6, which is equal to 18. Now I'm going to copy these down so that they're a little easier to reference as we go. All right, so now let's think about our next expression right here. So F prime of -2, again, we're plugging into our formula here. A prime of x, A prime of -2 is going to be 5, and then times the original C at -2 is 4, and then minus C prime of -2 is -3, and A at -2 is 3. And then we're going to divide by C at -2, which is 4 squared. And so that's going to get us 20 plus 9 divided by 16, just 29 over 16. And again, because of the double negative here, this becomes a positive. And then similarly, our expression, actually, let me move this a little bit out of the way. Here's our expression. And so we've got a prime of -2 f prime of -2, a prime of -2, that's going to be our 5, times b at -2 is 2, minus c at -2 is 4, minus b prime at -2 is 6, minus c prime at -2 is -3, times a at -2 is 3. And then in the denominator, b of -2 minus c at -2 quantity squared. And so if we do some arithmetic, we get 5 times -2 minus 6 minus a -3 is 9 times 3 divided by -2 squared. And we're going to end up with -10 minus 27 all over 4, which is going to be -37 over 4.